Well, hello.
Hi there.
Good morning and welcome. Nice to see a full room.
Yeah.
Did all of you get breakfast?
You're foregoing breakfast.
We don't want you grumpy. If you didn't get breakfast, don't fill out the evals.
Yeah. You should be well fed. Lots of endorphins in the brain and all that. Feeling all the good feelings, right?
Yes, and if all else fails, coffee?
Yes, coffee for sure. I'll start. My name is, I don't care what my name is. His name, I'm going to introduce him. This is my good friend, Mads Torgerson. He is the lead designer on the C# language. He is a swell guy and one of my dearest friends.
I have with me Dustin Campbell, who's he's a principal engineer on the .NET team, and his job, I think, is to make everything better. So right now, the thing we just discovered that when we add Dustin to things, they get better. So his thing right now is to make the WinForms designer better and actually make it great for .NET Core. And Dustin's a great friend and also part of the C# design team. So he's absolutely qualified to be here and talking about C# today.
Yes.
And that's what we'll do.
Let's get to it.
All right. So you're probably thinking, language, schmanguage, why do they keep adding things to this already wonderful
because
language
we want it to be
C++?
that's why.
So we actually, there's a meaning to the madness, or rather there's a rationalization of the madness, which we call the .NET language strategy. So a couple of years ago, we actually put out a blog post that goes into detail about how we think about C#, VB, and F# in terms of their role and their futures. And the essence of the C# strategy essentially are, I'm capturing just the essence. Go read the whole thing. But essentially, we want to evolve and innovate aggressively on C#. C# should follow and sometimes lead wherever the development community goes with the new opportunities and domains and kinds of apps and architectures out there. We want to follow. We want to be a language that you would pick up for your next project, not just use for your last project. So that's the ambition of C#, and we're taking that very seriously. As we do that, we realize that C# is being used for a raft of different things. Lots and lots of different domains embrace C#. Not all of them ones that Microsoft has traditionally pushed, and a lot of them are still outside of sort of the Microsoft domain. In particular, something like Unity, which is a great use of C# for hundreds of thousands or maybe millions of developers using C#. So the domains are vast, and we need to make sure that as we evolve this thing called the language, we try to evolve it responsibly in a way that the features are useful for many people. And finally, we, especially over the last half decade or so, as we've opened up, as the whole developer story at Microsoft has opened up and become open source and so on, we've engaged more and more fiercely in an ongoing community dialogue about the direction of the language. Instead of coming out of our caves every two or 3 years, and you came out of it.
I did come out of it.
We're still coming out of our caves, but in between, as we're in the caves, we're actually having this conversation. Luckily, there's internet in the caves, so we can have a conversation. So that it's not like, here's a big surprise that we've been working on in the dark in the labs for all these years. Here's actually what we all sort of agreed on and evolved together over time, and that leads to a much better product. But at the same time, it's important that you don't get a design by committee feel, and you don't just put in everything. And so we take very seriously to maintain a strong stewardship. Like at the end of the day, there's a small group of people, the C# language design team essentially, that tries to be the arbiter of the language, try to keep the spirit of the language intact, try to not put things in gratuitously that we'll regret ever so many years from now. Sometimes we fail, but we try our best to kind of keep a direction and a cohesion of the language, even as we have this community. So that's how we think about doing C#. Now, evolve and innovate is definitely what we're going to focus on today.
Yeah.
So this is the time of year where the yearly developer survey from Stack Overflow comes out, and I always like to check in and see is C# still doing well, and if it is, I put it on my slides. And so it is this year. So they have these various rankings of languages. You have to take it with a huge grain of salt. Who fills it out, and and stuff like that. But we'll take it with that grain of salt. Some of these languages are not what I would call programming languages, and so I'm just editorializing and pulling those out from all of these, and I'm then dragging out the top 10 of what I think of as programming languages. And so C# is holding steady. It's the number 4 most popular language in terms of people saying they use it. Okay, so that's a good place to be. We're happy with that. Cool to see Python edging out Java there.
Yeah, Python's going gangbusters.
That's kind of interesting, but we'll watch that one as we go. They also have most loved programming languages. That is, you're using it, you would like to keep using it. That's much more of a close race here. But C# is still in the top 10. We're happy. People use it in droves, and they love it when they do. Great. And then there's the most wanted programming languages. I'm not using it, but I would really like to. And again, C# shows up in the top 10. So I think, yeah, we're doing all right. We're showing up in the right places. And that's all I really wanted to say about that this year.
C# has a future, basically.
C# seems to have a future. Seems to be doing great. So we take the temperature. It's all right. So for the next...
Mike's dangling a little bit. It's a weird appendage.
Okay. Does it sound dangling?
It doesn't sound dangling,
Okay.
but I just
all
want
right.
to... Just looks like something's coming off of your face.
I'll try not to move at all. So for the next 35 minutes, we'll be talking about the next C#, which is imaginatively called C#8.
Yeah. We thought that was in order.
So we've been talking about what is the theme of C#8, and the truth is it's a grab bag of features, as always. But if there's this theme that kind of connects it, it is that we're actually focused on increasing the robustness of your code. There are many ways of saying it. It's sort of like raising the level of abstraction so it's easier to do the right thing and harder to do the wrong thing. Giving you more feedback that you are on a bad path, stuff like that. So making you more expressive in important scenarios so that you fall into the pit of success. It's easier to write the code, it's easier to read the code. That's the kind of features we like to add, right? So everyone's more productive and they're feeling more confident that they wrote the right thing. Does that make sense?
Yeah.
Want
to show some?
Get
Now,
away from these?
to be fair, we've shown a lot of this before, right? It's C#8, so this is the future of C# talk. So in previous past, we've touched on these things, but these are real things. I've actually, last year I had many hot builds on my machine. This year I have none. I have the preview that shipped yesterday from the preview channel for Visual Studio.
Yeah, it's community previews. You can follow along.
So it's more like it's a demo of some of the things that we've shipped so far. C# right now being actually in preview, right? So there's still more to come potentially, and fixes to some of these and changes to some of these language features over time until it's actually GA with .NET Core 3. But for now, this is what we've got, and it's looking pretty good. All right. So the application, we're going to try this differently this time. We've got one big application to go through as opposed to these little language demos where you mess with points and things like that and they're contrived. This time we have a different sort of contrived demo, and it's a toll calculator. Basically for calculating tolls as people are going over the 520 bridge on the north side of Lake Washington, which they brutalizes with tolls, whether you're a car or taxi or whatever. And the idea here is that what we wanted a system where you were getting information, getting vehicles from all sorts of different sources, different data sources, and they're disparate. So there's no like real object hierarchy here, right, of things. But we still need to be able to process that data. So that's kind of the application we've got. It's the best that we could do at the moment.
So we start out with a console application that is just sort of like testing out the logic, and then we'll switch to being more real-time later.
And a console application because we're language designers. That's the sort of demo we do, right?
And that's as far as I ever got personally.
We're the only ones that use that template. Okay. So let's just run this application. Now, right now, you see what we have here. It's just calling into this toll system, and we're just passing in a little bit of data. It's a car. There's 2 passengers. This is probably me and Mads. I'll just go ahead and run this guy. And in the console, we see that, hey, object reference not set to an instance of an object. So we have a null reference exception. Okay, that's so it's just like an application the two of us would write. So I'll go ahead and F5 so we can debug this.
Well, let's see where we're getting a null reference exception.
Yeah. Here we are. So this is a method that's used to actually do the toll charge. It calculates it and calculates premiums. They love premiums on these. And multiplies that together. But then when we look up the account, it looks like the account was not found.
It looks up the account for the license plate that came in.
Yeah, the license plate looks like
that. Apparently, that can be null. If somebody doesn't have an account and they drive over the bridge anyway,
right.
it's bound to happen, we get null back.
Okay.
Should have thought of that.
Should have thought of that.
But we didn't.
I wish I did.
And you always don't, right? We always don't. You're like, oh, it could be null? Well, thank you, customer, for reporting that exception to me after I shipped the product.
Yeah. Very helpful. Thank
you. So we wanted to do something about that.
Right. And so fortunately, this method here, if I hover over lookup account async, it actually shows us that null should have been expected, and we should have been doing something about that on our side, on the calling side. Right? There's a little question mark on account where in the result value, just signaling, in a way, declaring in the signature of the API that you should be expecting null to come back from this.
Right.
Right? Much like nullable value types, this is nullable reference types.
This is nullable reference types. And so nullable reference types is a new feature, major new feature in C#, which is that you get to say that something might be null. Well, you go, what everything might be null, all the reference types might be null. So, but what we want to do is to help you introduce a distinction between the ones that might be null and the ones that won't. Express that intent in your signatures and in all your declarations, and then we'll help you track it by giving you warnings when you don't abide by that intent.
But there's no warnings here because we didn't turn the feature on.
Right.
Because go ahead.
Giving you new warnings is actually a breaking change. If you upgrade to C#8 and you get warnings everywhere, you're like, they broke my thing.
Yeah, if you had build, warn as errors on your build, then we just broke your build.
Yeah,
right?
And so giving you warnings, this is a feature that in order to get the warnings, you need to opt in. And you can either do that in source code if you want to try out small. You can enable and disable the feature for any region of code you like, or you can just turn it on for the project. Right. And say, I like nullable reference types. You should always do that on a new project. I like these nullable reference types. I'd like to be told when I'm doing something dangerous. Give me warnings, please. Always.
And so I enabled it with a new
the new directive.
New directive. And there's ways to do this in the project file. There's all sorts of switches for doing this. This one I can actually enable and disable over various pieces of code. So if I have one method that I want to keep legacy, for example, I want to say, well, no, I don't want to get this because it's complicated, right?
Or I tested it well and I don't want to spend time on it.
I don't care. I can leave it disabled, right?
Some people are laughing when I say I tested it well. It's like,
oh, you and your ivory tower.
Oh, nice.
Imagining how software development works.
Yeah. He said testing.
Yeah. Okay. Now, so the first warning. Yeah. The first warning.
So now we turn it on and we actually get warnings.
Yeah.
Tell us about the first warning.
The first warning is that this is returning account, with a question mark, saying that's a nullable account. Unfortunately, we're assigning it immediately into a variable that does not accept nullable. It does not accept a nullable account. It is a non-nullable
So this is interesting. So we've now said that if you don't put question marks on your reference types, then they are non-nullable. We're going to try to prevent you from putting nulls into them.
Yeah.
So that's a big new thing.
Yeah, so the fix, of course, is add a question mark.
Yeah.
Right, no problem.
Okay,
or use var. We could use var.
Use var and edit for it.
But there's another error or warning rather right here, and that's that now that account is known to be nullable, it tells us that this is also possibly a null reference. You're dereferencing.
You're dereferencing null.
Maybe.
Shouldn't do that.
Yeah. Possibly null.
It found the bug. It found the bug that we had.
Yeah, and this in fact was a bug. That's excellent.
Yeah.
So it was definitely not engineered into the demo.
No, this is totally legit.
Totally live. Yeah, we just wrote this. Yeah. So we can work around that in a number of ways, but probably the easiest way is just to do what you've been doing for years, and that's just check for null.
Right.
Okay. And then the warning goes away. So it's doing all of the flow analysis to understand and flow the state of nullability state of these various variables and around through the source, through the data flow analysis to make sure that we can put the warnings and then know when we shouldn't put the warnings. The most important.
Right. So that's very key, that the warnings about dereferencing, they only show up if we think the thing might be null, and we being the compiler. And the compiler is very nifty about tracking the flow. And here it's seeing that you're testing for null.
Yep.
It could also see if you assigned a non-null value into the variable on the way here, right? Or go through branches and merge them and say, what do we know at this point about the nullability of each variable? And only if it thinks it might be null and you dereference it, will it give you a warning, right? So this is really trying to see through all the ways that you already check for null, and if you're doing a good job of it, it won't it won't warn you. It'll only warn you if you forget.
Yeah.
Mostly. Like there'll be a few false positives, or you're too smart for it, or something like that.
There's other
But
ways
that's
to
the
do
idea.
this, right? We can add the exclamation point. You know,
Right.
what do we call that operator? I don't remember what we call it.
Oh yeah,
I have a word for it.
Yeah,
but-
we have. I think we call it the null forgiving operator or the null
Yeah.
allowing operator.
You
If
put-
you want to say I know better, we have an operator for that.
Right.
It's like I know this will never be null.
I call it the damn it operator.
Yeah,
Sorry.
damn it
That's-
operator.
Damn it! I know what this was. Leave
And
me
then
alone, compiler.
you'll be grepping for those exclamation marks when you.
Yeah, that's not official spec language. So, now, Mads, so nullable reference types, great. One problem I see with this, just using my human engineering eyes, I noticed that if you just don't have an account now, you just get to fly through the toll and nothing happens.
Yeah, it's not
which
good.
sounds
Yeah.
like an ideal thing. And me being, on the language design team means I'm very prone to bureaucracy. And I would prefer that we do charge
Yeah.
everybody.
We should put ourselves in the shoes of the people actually getting the money out of this app.
Yeah.
So, hey, we got to charge those people who don't have an account.
Yes, we should
There
do
needs
that.
to be an else branch to that if.
Okay, so otherwise, yes, then we're going to do something else. And around here on the 520 bridge, I know that if you don't have an account, and they know who you are because you have a license plate number, that they will send you a bill,
Yeah.
right?
And there's a nationwide system where you can look up the license plates.
Yeah.
And so Big Brother's watching you here in America at least.
Yeah.
And so we can look you
owner.
up.
That's what we need. Look up owner async. That's
Yeah.
that's going to be. We need to await that. Now we've got the license plate number, but this guy, he doesn't take
State
the license.
and the plate.
Yeah, the license we passed in here, it has the state code at the end, but it's a single string. So we kind of need to
Yeah. So
get
there's
that out of
there's
there.
a string with a license and then a dash and then the two-letter state code.
State
at
or
the end.
province, yeah.
Oh, so we gotta do a little parsing here.
Okay. Parsing. Yeah, two
Oh.
characters.
Yeah.
So we could write it, and we should write it like, this way, substring, right? That's what we should use.
So that's the last two?
So we need the last two, so that's going to be like length minus 2.
That's
I guess we're going to the end, so that's not terrible. That's good, right? That's what we write
it's
today.
a little error prone.
It is error prone, and this language is supposed to be about robustness.
Yeah.
So instead, let's go ahead and use a range expression. And when I want to specify in a range expression, or just generally when I'm indexing into a string and saying just getting one character out, if I want to go count from the end, you can use a new operator. Again, I don't remember the name
I
for
think
it.
we called it the hat operator.
The hat operator.
Because
That's
if you
awesome
want to go
because
from the end, you have a hat.
it uses a hat. It looks like a hat. So if I want to count from the end, and I want those last two characters, I would say hat 2. Now I'm getting a character from there, but if I want a range, I can just say ... to make it into a range expression. So now I'm saying going from the two characters from the end, and then all the way up to the end, wherever that is. Okay?
Right.
And that should give us back that
Right.
code.
Which you could have said hat 0
I could have said hat
mean
0.
to the end, but you don't
Yeah.
have to. You can just leave it open.
Yeah. All right.
So just to be clear, range expressions don't
could
have
say
to.
that.
They don't have to have hats in them. You can go from the beginning as well.
Yeah, you
But
could
here
say-
we want to shave off
this.
those last two characters and get them out.
I mean, if you really, really wanted to, you could have said like, license length minus 2 here, right? But that's
yeah, you don't
that's
want
silly.
That's
Don't do
you want
that.
to use these.
Don't do that. Use these things.
Right. So in general, indexing and slicing much simpler. And now we can also get the rest of the license, the actual plate.
Yeah, and so using it similarly, we're going to go from the very front
Yep.
up to, and then we're going to go one less than we did before, so we lose that hyphen.
Yeah, because there's
right?
a hyphen in
There's
there.
a hyphen in there.
Right.
So
hat 3.
sure, there's no bugs in there, but I'm not going to run any tests, so it's fine. It's a problem for my future self.
Yeah, we don't write tests. If something's hard, we make a new language feature.
Yes. Over-engineering at its best, its purest form.
We have the power.
All right, and so now we'll have an owner, and I'm not going to test that for null either because it didn't say that it returns null. So I'm just going to trust that implicitly, that it's doing the right thing. And now I'm going to calculate a new toll here because our toll, well, if we had to send a bill as a bureaucrat, I want to add a surcharge.
Oh,
right?
yeah.
Yeah,
If we-
totally.
we have to
So
send them a letter.
We'll do that. We got to
They
send them a
have to
letter.
pay for
We got
that.
to pay for postage. Got to pay for emotional damages
Yeah.
to me. And so we'll pass the final toll, and then, I'm just going to go ahead and log this to our little logger guy.
To be clear, we'll send this bill to Canada if need be, but
Yeah.
no further than that.
no further than
All
that.
right, so So that's great. So we discovered that there was a hole in our functionality.
Yep.
We fixed the null issue, and we also
Yeah, and I
got to demo these range features in order to fill
it worked as a demo.
fill out the hole.
I'm actually I just pressed Control F5 so I could run it again, waiting for it to build. There's something goofy here. Takes a little bit. It's like, I'm thinking about building. And then the progress bar shows, and it's like, I'm done.
There we go.
But there, no longer is there null reference. Now we've also sent a bill to whoever that is. If that is your license plate, I picked it out randomly. I do not.
That was me right there.
Oh, was
Washington
it?
State.
No. All right. Next up, let's take a look at how these tolls are actually calculated. Right. Drill into this. Up here, we've got these two methods. Calculate toll and peak time premium. Let's see how that works. As I mentioned earlier, these vehicles don't really have any connection to each other. It's not like some meta vehicle class that everything inherits from. They're all disparate objects, right? And so you're going to have to use features that we introduced in C#7, like pattern matching, to match over these guys. Right. So and here we have occupancy charges, where if there's more passengers, we're gonna subtract or add. Similarly with taxis, if there's more fares. If it's a bus, we charge it differently based on the capacity. Really trying to get every nickel out that we can. Delivery trucks over weights and that sort of thing. So this is great. This is using C#7 pattern matching.
Yep.
That's goodness. I mean, we've updated to the future.
This would have been really nasty before C#7.
It would have been really nasty. It's still a little unwieldy with all the when clauses. It seems like, okay, this is really just if else statements really in disguise. But it's it still reads nicely.
But let's try to see if we can do more. Yeah.
What could we do?
Well, so first of all, the patterns we introduced in C#7 were all sort of top-level patterns. They would look at a value coming in and, try to apply to that. But sometimes you want to dig in. And what we're doing here a lot is digging into the object. Once we know it's a car, we dig into its properties.
Right. We just dig into passengers right here.
Yeah. So we've added what we call a property pattern. It's one of the recursive patterns. We'll see both of them, or all three variants of them. Depending on how you count, which is what this does is if you are a car, so you have the type check there, then we will dig into the properties that you mention in the curly braces and apply a pattern to them, to whatever value they have.
Right.
And so this will get the passenger's property of the car you just matched and see if it matches the constant pattern 0. Is that 0? If so, the whole pattern matches.
Yes. And we can use this all throughout. Whoops, that's not Control C. We can just use this throughout here. I'll just copy and paste these. And what's cool is that we get errors, right? And the errors, what's cool about this is that we're doing the analysis to know that, no, you've already checked for this. We've already pattern matched this, and the compiler is providing errors saying this case is already here. So
that's an example of what we said with trying to lead you into the pit of success.
Yeah.
By using patterns instead of just Boolean logic, the compiler knows more about what you are trying to do and what you have already tried. And you can see, hey, you already tried this.
Yeah, I'm going to go ahead and do this with fares, too. That's way prettier.
It'll fix the copy-paste error that you were likely to get here if you're fixing up the code.
Yeah, that was way prettier. I like that a lot.
Yeah, that's pretty
good. So we got rid of those when clauses. Huge for me. I hate when clauses.
I love them.
But, okay.
But, I mean, they're better than nothing. But.
Fine, we'll disagree. So looking at the next set of when clauses, though, there's not much we can do about this one. I mean, it's actually doing a calculation and reacting on that. It's got less than and greater than. We don't have range patterns yet, so we can't really check those.
Right. Still don't.
Yeah, still don't. But bus itself, if I go look at bus, it has a deconstructor that can deconstruct into the capacity and the riders. Now, deconstruction is usually used for things like tuples, where you want to take a tuple and turn it into a couple of local variables or assignment using the deconstruct methods. Well, we can also use those now in patterns. Right.
So deconstructors were a C#7 feature again, but now they can be used in patterns. It's another recursive pattern. So we see bus as a deconstructor. That means we deconstruct it into the variables that it deconstructs into, and then we apply patterns to those. But the patterns we apply here are just the var patterns. We just give those two values names, and then those names are in scope for the remainder of the scope of this this case here.
Yeah.
So
even with the when clauses, that makes me feel happier.
Right.
I feel much happier.
So extract the R and C what were the riders?
Riders and capacity. Did I do that in order or do that out of order? Did I just introduce a bug? I totally introduced a bug.
Yeah.
Nobody said anything.
We should have better intelligence.
I am super, super disappointed in all of you. This would have been horrible.
So yeah, that's like a Visual Studio feature, checking that the one-letter variables you introduce match up with the first letter of the thing you're using them for.
You can write that with Roslyn analyzers. I'm looking forward to your pull requests.
Right.
All right.
Okay, so that was the other recursive pattern is when
Yeah.
there's a deconstructor, or when you actually have a tuple, you can use the positional deconstruction instead of the property pattern where you have to name your way into the bits and pieces you want to pull out.
There's not much we can do with delivery truck, though.
No, that's fine.
That's fine. You know, if we had those range patterns, we might be able to do that in a property pattern sort of way. But
maybe C#9.
yeah. Maybe. Yeah, if we said there's a future, so if there is one, but yes. All right. So looking at this, though, it's so that's about as good as we can get with these switch statements from C#7 using kind of some of these new patterns. But there's something better we can do, right?
Yeah.
We could, this whole thing just returns stuff, right? At the very end, it throws if nothing's found. That could have just been the default case. We could just turn this into, it'd be nice to be able to just turn this into one expression that gets returned, as opposed to a bazillion return statements, right?
Yes.
And I'm not going to type that for you because that's tedious, and I don't have a refactoring yet. So, I can't
essentially,
crib off the IDE.
If old-fashioned switch statements were so 60s, then C#7 took them into the 90s by allowing patterns to be applied, and now we're taking them into into 2020.
So a switch expression, just converting this whole thing, would look like that. Same patterns, but now everything is a list of expressions. So matching that pattern and returning a single expression.
Okay, so this is a little confusing to me. Not really. But,
no, not really, but for instructional purposes.
So what you have is that now the calculate toll method is an expression-bodied method. There's an arrow, and then everything after that is a single expression, which is a switch expression. You walk up to the vehicle and you say, switch on that. And now you have cases inside, but we don't use the case keyword because that's clunky.
Right.
And we don't use the colon. Instead, we have the pattern followed by an arrow, like a lambda arrow, and then what's the result of this expression if that pattern matched?
Right.
Okay.
So in a lot of ways, this is like the arrow up here, right? Just returns a single expression.
Yeah. So interesting. So that's all cool. At the end, though, we didn't have a default in your statement, but you have that. What happens if you comment that out? That catch-all there, that discard pattern.
So then I get a warning on the switch that tells me it doesn't handle all possible inputs. That is, it is not exhaustive.
Right. Because when you're switching and your result is a value, as opposed to just some statements getting executed, it's really important that a value does come out. So if you have some cases that could come in that you don't handle, then what should the switch expression result in? So switch expression is going to check as best it can that you actually handle all the inputs that you could get, and give you a warning if you don't. And so if we were forgetting to deal with the situation where it was none of the above, then it's going to remind us to. And now it sees that there's a catch-all in there, nothing could fall through, and everything's handled.
Now, one other thing that I think is cool about this, the switch expressions, because switch expressions are expressions, they return, a list of, of possible matches that return a single expression, but that single expression can also itself be a switch expression.
Oh, that's true, yeah. And
so right here, I could say, well, I could turn this itself into a switch expression where I'm switching now on passengers, where if, and we'll just kind of put some curlies in here, and if, let's see, if I say 0, and I can clean it up like this, which I think is fantastic. And so we can have nested switch expressions in here. Whoops, no, I did need that. And right there, and enter. And that's exhaustive.
That's another nice way of writing it, right?
Yeah.
So recursive patterns, one way of digging in. I switch first on the car, then in the next level down, I switch on the passengers when I know it's a car. So that's also really neat.
Yeah. Now, we could do that with fares as well, but you just watched me do it with passengers, and it took me like an achingly amount of time. So we'll just step on past that. But we have a couple of other warnings in this file, and that's because we have two other functions that return switch expressions, and they are clearly exhaustive, right? But they still have warnings on them. They seem to be exhaustive. I mean, I don't know of any other days of the week yet.
Yeah,
but
the problem with enums in C#, and we're not, by the way, we're not solving this time around, but we're thinking about it, is that you can convert any int value into an enum. They're not limited to the listed values, so you can never trust that they're exhaustive. And sometimes people have flags where they actually combine them and so on.
But the nice thing here is that several of them just return true. The real thing we care about is the weekends, right? Because if I do this, I just want to handle all of them and say, if it's a weekend, then we're going to say it's false. Otherwise, just return true. Now, that's going to give us an error because, of course, we're handling...
You're handling everything, so you have to move it to the end. That's a catch-all.
Put a comma in there.
And if another day of the week is ever added, it's bound to be a work day. I'm just sure of it.
Yeah.
So this will hold up to time.
Yeah. I think no test. It's fine.
Right.
We know that'll be true.
What do we have here?
Well, we have a similar problem. We have this giant enum, time band, not to be confused with time bandit, and it's got the similar situation where we've got a whole bunch of values we're returning, and it seems to be exhaustive. It's like all the possible permutations of the two booleans, and then all the enums, but it's still not exhaustive because, again, that enum itself is not exhaustive. Right.
These are the multipliers for peak hours
that
we're computing here. And this is listing out all the cases that we can think of.
Yeah, the bureaucrat in me does like all the cases there. But really, when I look at this, I see that everything down here, everything where it's the weekday, where it's not a weekday, is always 1. So it seems like it's probably a little over the top. I know that sounds weird for the bureaucrat, but it sounds a little over the top. And we should probably just say, no, everything.
Remove all those,
these guys can go away.
Well,
then we have a couple other that return 1 that are just these cases where, like, if it's the morning rush and I'm outbound, we're not going to charge you extra.
You're not charging you extra unless you're going into town.
Same if it's an evening rush and we're going inbound. Okay. So we can get rid of those.
Leave those to the default.
Okay.
And some of them are the same, regardless of which direction you're traveling.
Right. So we could say instead we could combine those into one. Say we don't care if it's true or false.
Yeah.
We just care that it's.
Hang on.
Sorry.
Can you introduce that one again?
Sorry. Oh, yeah.
I just want to put the discard in.
Oh yeah.
And wait for a second.
Yes, because you want to see that there's an error now.
Yeah. See, it says you already dealt with both true and false. Gives you an error.
Yeah, that is cool.
So.
And then similar down here, right? Do you want me to pause for that?
No, it's fine. I think
moment?
we got the point now.
Okay.
I think we got it. You making fun of me?
No.
So
it's fine.
This is actually great because it's very clear we're dealing with all the special cases, some of them lumped together with a discard here and there, and then there's the default case, which is the multiplier is just 1. And it's very easy to read.
Great. And so everything still works. We've refactored this to death, but everything still works. And this is kind of the improvements we made to pattern matching, kind of filling out and finishing out that story as part of C#8. Okay, and that's in builds right now.
Great.
All right.
Okay, so now we played around with our console app. Let's actually get to the real deal. We have a camera out on the 520 bridge, and we're actually streaming data live into this room as we. No,
that's not live.
It's not that real.
It's not real. There's all sorts of problems with that. They're going to put this up on like the internet. This video. That would be awful.
They don't yet have a live public feed where you can get all that data.
But we have another application. We have another project that's calling into this, and it's calling into the same system, right? To basically, it's going to give us some buttons on the bottom. Whenever it finally does come up, I mean, those of you know that I have press Control F5 right now, and I am awaiting. This is async build.
Right.
And I must await.
So the idea is that we have a UI where we can simulate that a car or a truck or something comes, and we'll generate some random data from that.
Right.
Here we are.
Yeah, so we can simulate. We're just passing these into the system, and they get logged. And these are just randomly generated, right? They're just like, okay, it's a car, it has a random number of passengers, buses, taxis. But the problem is, and I can already see this, and again, I'm not real happy about it, being my job is to charge people. And instead I'm not charging anybody. At least I'm not getting messages that anything's being charged. Right? That's because we haven't actually implemented that part of the application.
Right. We haven't hooked it up to the logic.
We just haven't hooked it up yet. So let's go do that. We've got, I'm going to write a method here. We're going to call it charge tolls async, I think. It's a good name. Charge tolls async.
Right.
I love making people watch me type. Okay, now on our toll system class that we've been using, that we used in the console app, there's this charge toll async. There's also, there's also a get vehicles async that we probably want to use and iterate over all the vehicles that have passed since the last time, and then go ahead and charge each of those.
So that one's super interesting.
Yeah.
Because it's returning something that we haven't seen before. It's returning something called an async enumerable.
Right. Now, I also want to be clear about one thing. This type is there right now in .NET Core 3. This is just a .NET Core 3 WPF app. I've done nothing else. I've added no packages. It's just plain vanilla. So this is already there in the latest .NET Core 3 bits.
So async enumerable, maybe you can call it and we can start playing around with the async enumerable when we get back.
Yeah. So we get this guy back. Now, I don't know how to call it. It doesn't say it's a task, right? It didn't say it was a task. It returns async enumerable. How do I actually do something?
How do you consume an async enumerable? When async enumerable is like an async version of enumerable. Well, name kind of says that.
Yeah.
So it's sort of like an async stream, right? It gives you values when you ask for them, just like an enumerable, but it gives them to you asynchronously. It might take some time, and you can await the next value. But how do you do that? Well, there's language support for that. Instead of just awaiting a single value, which you do with a task, you can await for each an async enumerable. So in an async method, you wait for each it, and that means that the for each loop will just await every time that the next value isn't ready yet. So it's an asynchronous way of consuming async live streams, like the data from IoT devices and sensors and stuff that we're getting here, or anything that's produced out of a streaming service or whatever, like anything that is discrete values coming in real time can be represented by an async enumerable, and the language helps you consume it with the await for each feature.
Right. So what we've actually set up here, we're actually setting up a little pump, right? That'll, you know, as vehicles come in, we'll be awaiting and we'll get the next vehicle and then we'll charge it, right? And so we kind of set ourselves up a little pump. I just need to kick it off, right?
Right.
And so I'm just going to do that.
So you
run on the WPF dispatcher and
you run that method once and for all, and it's now sitting there in its loop, looking at that async enumerable, and every time something comes in, it does something with it in the loop.
And so, you know, we'll see it. You know, now bills are being sent. Now, if I click this real fast, you'll see more cars go over, and then over time, those charges will be sent out.
Yeah, as they come through the stream.
And it's that easy. Now, it seems like, though, this thing, now, last year we showed async enumerable, and it was a little smoke and mirrors because I had to go implement it. And it was like a nightmare to go implement at the time. And we have a differently shaped API today, but it was very complicated. So let's take a look and see what we actually had to do to implement async enumerable.
Yep.
It doesn't look like, the most scary part is the definition of this tuple right here, right? We literally just said async enumerable, get the vehicles async.
It produces tuples out.
And we yield. Right?
It's just a yield return, just like any other iterator.
It's an iterator, but it's an async iterator.
You have an async method that returns async enumerable of something. You can just yield return that something. The compiler will generate the implementation of the async enumerable.
So that horribly complex async state machine for async enumerable, don't write that.
Right.
Use an iterator.
So everything is sort of a one-to-one with the synchronous world. Instead of synchronous single values, you have tasks of those, and in asynchronous enumerables, you have, or synchronous enumerables, you have async enumerables to correspond to that, and language support for both. The only thing that is a little more complex with async, which we can't show yet because it's not quite done, is that with async you often have cancellation tokens flowing through, making sure and so the compiler is also going to support flowing cancellation tokens through when you use async enumerables. So you can have a button to press and say stop doing that. I'm done.
So what do you guys think? Async iterators? Cool?
All right.
Okay. Okay. You've been very, very quiet. I assumed you didn't need the extra caffeine.
You asked for applause.
I kinda. I'm sorry. I'm sorry. Right. It made me feel good. All right. Okay. So that is our async enumerable. Now, one other thing we'd like to do with this application is there is a button there that I didn't click that you probably all saw and were hoping I would click because, you know. And it's this one. And all it really does is it passes null in, right? And then we get an exception back. But actually, we don't get an exception back. It logs an error for us. right? But what if I really did want to get that exception? I'm in this application, and an exception occurred. I want to get it back, but it came through this logging system. We have this iLogger over here that it calls into. It just passes a message. What if I wanted to get the exception out? Right. Well,
in other words, what if you want to add another member to an interface?
I would add another member, and I would do it like this. I like to break the world because that's what this is going to do.
That.
Right?
You can just add another member to an interface. But you just do it.
But I like breaking the world, and this does break the world, right? If I build this, everything. Yeah, there they are. Everything will fail, right?
Every implementer of the interface is broken.
There's two, right? There's one in the WPF application. There was one in the console app.
And we happen to own these, so we could go fix them up.
Yeah,
but
we could do that.
You publish an interface, it's locked forever because somebody out there is implementing it, and if you change it, you break them.
Yeah.
You add another member, you break them, you put a new requirement on them to implement it.
Yeah, I can call it. That's great. I can do that right here,
right.
And all's good. But the problem is that what I really want to do is I wanted to say, well, if somebody doesn't implement that, I want to do this behavior. The behavior that was right here. I want to do that, right? So
that's like default behavior.
Default behavior, yeah. So I'll come back in here, and I will just give this an implementation using expression by member, and we'll just say that. And now everything still builds, okay? Which is great. It builds again. Now the problem here is that we didn't really do anything. You're all sitting here going, why would you do that? That seems unbelievably complicated for something that an extension method is great for, right? And yes, you've all come up and said that in years previous, as we've shown this. But
not all of you.
Not most of you. But what I can't do with an extension method is then create a specialization of that particular interface member on one of my implementers, one of my types that implement it. So I can come over here to my iLogger and say, you know what, actually, when I get an exception, I want to do something different, right? It's because it's actually an interface member that I can come and implement. And we'll go ahead and, I don't want to call it item, we call it EX, we'll scroll it into view. And now I've actually got a different data template set up for exceptions when there's exceptions in the list. And so when I press boom, now I get a stack trace and stuff in here because I actually have the actual exception. And so that's what is super powerful about these things, that I can now, evolve an interface without breaking every implementer, right? And you might say, well, couldn't I have used an abstract class for that? I was like, yeah, you could, but you're going to bend over your application to do that, right? You have to twist it, because in this case, well, this is the main window, and that's where we implemented iLogger. Now, maybe I should have put that on a separate type that could, descend from that abstract class, but I don't always have the ability to do that.
You're already deriving from another class. You can only derive from one class.
Yeah.
So the point, again, default implementations and interfaces. Your members and interfaces can now have bodies. They're just, suggested implementation. They make it so that people don't have to implement that member, but they're welcome to, right? You don't have to take that default implementation. It's just for if you didn't know about it or if you liked it very much, right? You just keep it. So it gives you that flexibility on both ends, which I think strikes a really good balance.
Yeah. Are you ready to go back to slides?
Oh, sure.
We should talk about the future.
We should talk about the future. This is the in the fall future. This is for when September or when .NET Core 3.0 ships and we ship C# 8 as well.
Yeah.
But there's a future, which is what happens with C# after that. And one thing that
falls over the crowd.
Woo! The lights went down.
Yeah.
It's like
weird.
This is a trailer for the next generation of Marvel Cinematic Universe movies. Never seen before, except on GitHub.
Right.
One thing that was interesting about that last one is we changed how interfaces work. That's not something we can just do in the C# compiler.
Right.
That's something that's about how the runtime works. We haven't actually changed the runtime to enable new language features since generics in 2005 is when they shipped. Because we couldn't, because too many people were dependent on different versions of Windows, and they had different versions of .NET running, and things would break if it was, Now, with .NET Framework 4.8 officially being the last version of last major version of .NET Framework, and with all the innovation going into the .NET Core track and actually merging together into the .NET 5 with Mono and everything coming together for .NET 5, now we have a stack that's not only it's a single stack that we can innovate on. Remember that first bullet of our strategy, but we also are able to control and modify and evolve every single component of our tool stack, from the tooling down through the compiler, down to the libraries, down to the actual runtime, because of the way we can now deploy. Right? You can, if your program depends on the latest, you just get the latest. And that gives us an enormous freedom to innovate. And we already started using that a little bit. We scratched the surface with this interface feature here. But we could do that so much more now.
Yeah.
And so what we're going to show you now is not maybe the sort of pedestrian next level of features that will probably show up in C#9 or so on.
Yeah, I just want to be clear. I don't want to see any articles that, guys, that say like, this is C#9. We're kind of, unveiling a couple. I mean, these are things we talked about publicly, but they're also things that we're dreaming about.
Right. This is us dreaming about what could we do with the help of the runtime, evolving the runtime. What are some of the big abstraction-y things we could do in C# going forward now that we have this freedom? So with that caveat, let's talk about some of the things. Starting with something that we've sort of been waving about for years. Okay. What if you had a super terse syntax, we can call them records or something else, that really meant this is a data class, and it has all the non-default behaviors of a class. It has, it is immutable, so it has getter-only properties. It has a constructor and it has a deconstructor because it's positional. And it has value-based equality and hash code and so on. And it has all these behaviors.
We've been showing this slide for years, and everybody's like, why haven't you done it yet?
So they're like, why haven't you done it? Why can't you just generate that? And we'll sort of get to that a little bit. But part of it is that I actually say now that
I know, Matt. I want to answer. Why did we do this?
The compilation strategies that we would use for doing something like this today result in very brittle code. We can get this functionality running on the current runtime, but there are all these innocent-looking little changes that you might do to your source code that would break the relationship between types when they're generated into. We need some CLR help to do this right.
Right.
So that's the realization we came to.
Because records, when it comes down to it, when you look at them in runtime, to you, the consumer of those objects, they're going to look like regular reference types or value types, right? But as soon as you start poking on them, if they start doing different things because they happen to be records, well, that brittleness starts to crack and things start to flake off, and now you need to know that you're talking to a record, and now has it really helped you all that much? And so we're trying to figure out ways around some of those problems that compilation is just seems not to be working.
To be honest, we did too many features in a brittle way in C# over the past. We did great features like lambdas and async in the past. We did them all with compiler tricks, instead of building the notions of closures and state machines and so on into the runtime where they properly belong. And because we did it the wrong way, they're still awesome features, but there are all kinds of seams that show that people start depending on, and now we can't clean it up. Maybe we'll look at that in the future, trying to see if we can pull those things into where they belong, where the runtime can understand them and optimize them properly and all that. But because we didn't want to tinker with the runtime back then, we did a suboptimal implementation, and we don't want to do that again. We want to build things where they belong, and now we can. So a few more things about records. You may not want them to be ordered. You may just want to be able to say, I have a data object with these properties in it. You would probably want to use object initializers on. Object initializers is this kind of feature that only works through mutation, right? So you're sort of encouraged to leave your object mutable and vulnerable, just so that an object initializer can be applied to it. What if there was a feature in the language so you could have object initializers applied to immutable objects? That probably requires some runtime help. And if you had immutable objects, sometimes you want to create like the next version of it. Right? That's a little different. This field has been changed, but this is sort of the next version of what that one represented. I'm not saying that Scott Henselman is the next version of Scott Hunter, so it's a bad example. But the idea that I have P1 and I want to create another value that's just like the first one, except for this one or two fields changed. You could use object initializer like syntax to create a new object from an existing one with a delta in a strongly typed way and efficient and all that. That's another thing. Something that is really hard to deal with here, and part of why we want runtime help, is once you talk about records and inheritance, these things become hard to implement, and we have to we have to figure that out in a robust way.
Yeah, because as soon as you have that person there, then it's, you want to put a customer there, right? And then you want to inherit the things from the person and not declare them again.
Right.
And that's really hard. Yeah.
And another thing, we kind of touched on it a little bit with the exhaustiveness checks of our pattern matches before. Sometimes, the problem with inheritance is great for like, okay, I have this base concept and I have all these implementations of it, but it's open-ended. You can always add another one. And that means it's really hard if you do switch expressions or something like that. It's really hard to know that you got through them all. You have no compiler help for that. Many functional languages have a thing called discriminated unions, which is essentially a closed set of derived types, if you will. It's like this type can only have these 4 different things, and that's it. It can only be look in these 4 different ways, which means that you can check that you thought about all 4. So you could do that all the way down from just enums being closed off and having only a set number of values, all the way up to different classes being the only possible derived classes from a given base class. Is kind of how I want to say it.
Yeah.
So that's something we also want to look into. So that's kind of that express your data, kind of your data shapes better, kind of realm of features. Now I want to go into something that's
It's more about being, doing expressive things with your data, but it's a little more head spinning.
Even weirder. This is sort of like abstraction next level, abstraction 2.0. Right?
Yeah.
So thinking about what are the places in C# today where we lack the abstractive power, the ability to express something abstractly and be general or generic over something. One of the common things that people complain about is it's hard to write a shared algorithm for different numeric types, for instance. We have notoriously bad, and we share this with a lot of languages, but we have a notoriously bad numeric abstraction in C#. Well, what would I like? Well, I would like generics. I would like to write a generic method that takes a bunch of things and adds them together. Okay? That's a simple example. If they're not zero, add them to the result. Accumulate, whatever. But I can't today because there are a bunch of things I need that can't be expressed as a generic constraint. I can use an interface to say that there's an is0 method on the value, but I can't say that there's a plus on the type, or there's a static method that I call there t.0. I can't say these static things in an interface. I can't put requirements on the class as opposed to its instances. Well, what if I could?
That'd be a good idea.
What if interfaces?
Why didn't we do that years ago?
What if interfaces could express static members as well? Right? So I could say, there's an interface is calledimonoid. It's because this corresponds to the mathematical object called a monoid.
Oh, I thought that was because you were like a pretentious academic and you used words like that.
I actually used slides like these ones where I said I group, and there was an even more pretentious member of the audience who said, that's not a group, that's a monoid. You're wrong about your math.
My. It's not like this audience at all. I had no idea.
So, okay, it's a monoid. So anyway, it's a thing it's a T that has a plus operator, which is static. Operators are static. It has a 0 property that you can get the 0 of this type, and the neutral element of this type, and then it's something that you can check if a given value is 0, as an ordinary property that you have today. So we extend interfaces with the ability to express those, and then we put that interface as a constraint on a generic method, and now we can implement the interface on common types like int. And we can say int implements imonoid of int, and add these extra static members and these extra members that int doesn't already have. We could make them explicit implementations if we don't want them to show up on int.
But it already has a plus operator, right?
It already has a plus operator.
Yeah.
We don't have to put that. It already has that plus operator, and that would satisfy the interface. So now, by just using ordinary interface and having this static member thing, I've been able to do generic abstraction for number things and all the other kinds of things you want to express in statics rather than on instances. And so now I can call this add-all generic method with an array of ints. And we have numeric abstraction in C#. That'd be pretty cool, right? Yeah? I love that you applaud something that we don't even know how to build yet.
Yeah. We are so dreamy about this stuff.
We're winning. We're winning.
We're winning.
So, so that's that. Static members and interfaces, that's something we're going to look into. We actually had a prototype several years ago and it worked
Yep.
fine. We just couldn't ship it at the time because it needed runtime changes. Right? So now we're digging that out again. There's a problem here, which is switching gears. There's sort of a software composition problem in this particular example, not with statics in general, but just in this particular example, is that I'm putting an interface, another interface on a very popular central type. Right? All kinds of reasons why I might not be able to put that interface on int. Right? It might be that, you know, I'm me and I don't own the core libraries and I can't just go and put my interface on it. You know, it might be an interface that's specific to me that I want int to satisfy so that it can be adapted to some generic machinery over here. But int, it doesn't make sense for everybody using int, and int shouldn't know about this concept that the interface embodies. Right? You know, maybe if I did that anyway, if we sort of like push through with it, there might be so many interfaces that you want to add to core types like int that it's just overwhelming and silly. And you know, finally, there might be different ways to implement that same interface for a given type, in given contexts. So there are all these reasons why putting another interface, adopting this strategy of just slapping interfaces on types, it's not always great, or it's not always possible. But I want to. Okay, we're done.
And yet I want to.
So what could we do? Well, let's step back from that, keep that in the back of your minds, and then think about places in the language today where we have a similar situation. I wish that type had this method. It would make sense for my domain if int had this method, but it doesn't. Well, I'll add it as an extension method. Done. And people have been saying to us for literally a decade,
More than
why can't I have extension properties? You know, why can't I have extension indexers? Why can't I actually have extension static members and all that? And
we call that
were
extension everything,
extension everything. Give me
Yeah.
extension the whole thing. And we were like, yeah, but unfortunately, we backed ourselves into a corner with the syntax of extension method
Yeah.
declarations that doesn't generalize to those
We
other
are so evasive about that one.
So let's say, okay, let's back out of the corner. Let's say we made a mistake, not with extension methods, but with how they are declared. And let's have this new way of declaring extension things that's more general. You have something like a type declaration, and this syntax is not set in stone at all. It's just strawman syntax. Something like a type declaration that say, this is an extension for that type, and here are all the members that I want to add. Just using this and everything in them. Just write like you would write them as instance or static members yourself.
And so, Matt, what would the scope of this thing be, though, right? Would that be for everybody, or what's the...
No, it's kind of like extension methods today, that you can pull it into scope with a using or something.
Oh, I see. So you could have different int one,
So-
it's for different parts of my program,
Yeah.
for example.
Yeah.
Okay.
So now I can add, at least I can add those extra members to int. The property, the static property. So I can get those members, but I'm still not satisfying. So that's good. Now I can call int.0. Awesome. I know now what the neutral element of int was, if I didn't before. Neutral for plus, that is.
Right.
But it doesn't solve the problem I was talking about before, because I'm still, even though I have the right members, I'm not satisfying that interface. Well, what if an extension could also do that? What if I could slap an interface on one of these extension declarations and say, using these members that I'm just introducing as extension members, plus whatever members the thing already has, like the plus in this case, so plus plus, implement this interface. Whenever this extension declaration is in scope, whenever all these extension methods is in scope, the fact that int implements imonoid is also in scope. Right? It's just this local thing that I'm bringing. For me, int implements imonoid. Not for you, not for everyone else, just whoever implements this.
That's really galactic space-time kind of stuff.
Is that crazy?
Yeah, that's pretty cool, though.
I am implementing imonoid for int. Over here, not owning int, not owning imonoid, I can do that. That's what this feature lets me do. So you can see,
Shipping sometime for your children.
yeah. So you can kind of see how this might need a little bit of help from the runtime. Because that's how, but that's something we're exploring and seeing if it even hangs together semantically and what are some efficient data structures we can have in the runtime that can actually work in practice. But that would now let me call add all with ints, even though add all requires something that implements imonoid of int, and int doesn't inherently do that. So we think that's pretty cool.
Yeah.
And there's sort of a related thing that I just want to breeze over quickly that we're also considering. Which I think is going to get very important in this age of consuming data that's, not very structured and not very strongly typed, right? So you have your JSON object or something. Oftentimes you have some dictionary-like thing representing data that you got over the wire, or that you're about to send over the wire. And working with those is kind of like, you can use dynamic, or you can use indexers and strings and stuff. But it's kind of like you're without the guardrails, and you're just making, it's like programming in JavaScript, right? You don't,
for some definition of programming.
Except even uglier, and you're like, does this work or not? Who knows? So the idea being that maybe we could let you put, without changing the runtime representation, maybe we could let you put strongly typed overlays, like perspectives on these, that are like, I want to view this as an order. An order has these strongly typed members. I want to view this as a customer, and now I can write strongly typed code over them. They can still blow up if I lied when I viewed them as that thing in the first place, but at least all the logic can be written in a strongly typed fashion. That's something we're also looking at.
Yeah.
And maybe those roles could even implement interfaces too, but let's, So that was what we had about the future of C#. Here are the places you should go to learn about what we're thinking. Look at the docs. The docs are awesome. And they have try.net things coming in where you can write code live in the docs and try new features out. Look at the language strategy if you want. Go to GitHub if you want to follow along in the messy language design process that takes place there.
Very messy.
And come and see us at the booth. We'll be there from 11:30 today, for instance, the C#, F#, VB.NET booth in the Expo, and we'll love to talk with all of you about all of it.
Yeah.
Thank you very much.
Thanks, guys.